Welcome to Basic Electronics video lecture. In this lecture we study the BJT, Bipolar Junction Transistor, which is the unit 2 of OU syllabus. Now what is BJT? BJT is a three-terminal semiconductor device in which the operation depends on the interaction of both majority and minority charge carriers, and it is a three-terminal device and which is used for the amplifier and logic switches. Now these are two types of transistors are there. One is a PNP transistor and another one is a NPN transistor. Here you can see the diagram. Now here transistor, this is a symbol for the transistor. It is already I said that it is a three-terminal device. Those are emitter, base, collector, and here also this is the NPN transistor, meaning is P material is sandwiched by the two N materials is called the NPN transistor. And coming to the PNP transistor, here also three terminals are there, same emitter, collector, base. Difference is here the N-type material is sandwiched by the two P-type materials is called the PNP transistor. And if you see the circuit symbol, this is the circuit symbol for the NPN and this is for the PNP, where the arrow mark is outside and here it is arrow mark is inside. This is the circuit symbol for the transistor. Now transistor construction. So here this is the NPN transistor. P material is sandwiched by the two N material type is called the NPN. Now here if you see, this is the emitter region, base region and collector region. And here the base is a very thin layer and emitter is a moderate and collector is a large in size. And coming to the doping concentration, emitter is a heavily doped material, base is a lightly doped material and collector is a moderately doped material. The name here it is saying emitter should emit the charge carriers and a collector should collect the charge carriers. This is about the construction. Now in the transistor is having two PN junction. One is, now here you can see emitter base junction, this is one PN junction, and another one is a base collector junction, this is called the junction 2. Now here we have to apply the bias such that already we have discussed the forward bias and reverse bias in the unit 1. Now here we are applying both bias to the single transistor. Now if you take PNP transistor, so need to apply the forward bias to the junction 1 because the emitter should emit the charge carriers, for that need to apply the forward bias, and the collector should collect the charge carriers, that's why we need to apply the reverse bias at the junction 2. Now what is forward bias? Now in this case P and N junction, now this is a emitter is made up of P material and base is N material. To make this junction forward bias, P material should be connected to the positive plate of the battery and N base should be connected to the negative plate of the battery. Now with this we are applying the forward bias to the junction 1 or emitter base junction. Similarly for the output side or junction 2, this is the base collector junction and it is base is made up of N and collector is P. So we need to make a reverse bias at the output junction or junction 2. So collector is made up of P. To make reverse bias we have to connect the negative terminal of the battery and the positive terminal is going to the base. Now like this we are applying both the forward and reverse bias to the single transistor. Similarly for the NPN transistor, here emitter is N material. To make the emitter base junction forward bias, N material should be connected to the negative plate of the battery, and similarly base which is made up of P is connected to the positive material. Thereby the junction 1 or emitter base junction is forward biased. Similarly now here output side or junction 2 need to connect a reverse bias. So here collector is made up of N type material that is connected to the positive plate of the battery and negative plate is going to the base which is made up of positive material. So this is about the biasing of the NPN and PNP transistors. Working of PNP and NPN transistors. Already we have discussed this. It is having the two junction. Junction 1 is forward biased, junction 2 is reverse biased. So when the junction 1 is forward biased, so from the positive plate of the battery, now holes are entering into the P material. Now here in this majority charge carriers are holes which are moved towards to the junction 1, and it will cross the junction and enter into the N-type material. Now where in the N-type material majority charge carriers are electrons and it is very lightly doped, so here the available electrons are very less, and these holes will recombine with these electrons, and it leads to the IB current, and the remaining excess remaining all holes will enter into the collector region, and here the collector is connected to the reverse bias. This negative plate will attract those charge carriers which are entering from the emitter to the collector. So this causes to the IC current. Now in this, the total current IE is equal to, which is generated by the supply. So total current IE is equal to IB plus IC. Now where the IB is in the order of microamp and IC is in the order of milliamps, and here IE is also in the order of milliamps. Now because the IB base is a lightly doped, here the number of charge carriers are very less, and current here in this junction, in this region is very small in the order of microamps. Now if we see, if this IE is almost is equal to IC. Now whatever the charge carriers are induced in the emitter, almost it is reaching to the collector. That's why emitter current is equal to, almost is equal to IC. And coming to the NPN transistor operation, now here instead of analyzing the holes, if we analyze with the electrons, then the operation for the NPN transistor. Now this is the NPN transistor diagram. Now here electrons are injected into the N-type material, and it is crossing the junction and entering into the base, and there in the base majority charge carriers are holes. It is recombining with the hole, and it leads to the IB current, and remaining all electrons are entering into the collector. Now here also IE is equal to IB plus IC. Now this is the current direction in the NPN transistor and PNP transistor. So this is the symbol for the NPN transistor. Now here this arrow mark indicates the conventional current direction or positive current direction. Now here in the NPN transistor, arrow mark is outside. In the PNP transistor, arrow mark is inside. So from the emitter to base, charge carriers are injected. Now from here NPN, now here from the base to emitter, charge carriers are entering. So here this arrow mark indicates the conventional current direction. Now if you see the currents, total how many currents are there? 3 leads are there and 3 currents are there, IE, IB and IC. If the IE, now just now we have seen that IE is equal to IB plus IC. So where if the IE is the entering current, then IB and IC are the leaving currents in the case of PNP. And coming to the NPN transistor, this arrow mark is indicating the conventional. If the IE current is coming out, means IB and IC both are entering into the transistor. This is the current direction in the NPN and PNP transistor. Now there are 3 types of configurations are there. One is a common base configuration, common emitter configuration, and another one is a common collector configuration. So because the 3 terminals are there, now we can call it as this is the input side and this is the output side, and the terminal which is common to the both input and output is called as name common base. Now here the base is a common to both input and output, that's why it is a common base configuration. Now in this case the emitter, now here you can see the arrow mark, emitter is common to the input and output, that's why it is a common emitter configuration. Now in the common collector terminal is common to the both input and output, that is a common collector configuration. If one terminal is a common, then the other 2 terminal, one is for the input side and another one is the output side. Now coming to the common base, in this common base, emitter is the input terminal and collector is the output terminal. And common emitter configuration, emitter is common and base is input, collector is the output terminal. And common collector configuration, collector is a common terminal, base is the input and emitter is the output. So these are the three different types of configurations are there. In the next lecture we see the common base configuration.